Hello everybody, today we are going to be taking a look at this problem, binary tree level order traversal. Hopefully you guys are familiar with binary trees and trees in general and what they are, and if not, you can look at some of my past videos. But essentially, a tree is a structure that looks like this. There's a root node, and connected to the root node are in subsequent, each node is considered a parent, and they have children. Specifically, a binary tree would have up to 2 children on each parent. Each parent node can have up to 2 children node. So it looks something like this. So now, how would we go about creating a method? First of all, let's talk about what the level order traversal is. As demonstrated, a level order traversal is going from left to right, level by level. So we need to list all of the values in the tree. So starting from the root 3 here, and then it goes from 9 to 20 to 15 to 7. Because that's how the level order traversal works, left to right, and then up to down. And you can see on the side here, I also have an image here on the side. It's a little bit blurry, but it's basically starts from 5, and then you can see how the level order traversal lists them all, starting from top to bottom and then left to right. Top, left, and then it goes to right, and then bottom left, and then keeps going like that. Alright then. So yeah, now that we know what our problem is, how to do a level order traversal conceptually, we need to know how to code this. First of all, we need to start by constructing the tree in the first place, right? So to make our tree, give me 1 second. We can create a tree node. So we would need to make a tree node. So we have a class, and we are going to call it tree node to create our first tree. You see, so each tree is a specific node. Each node on the tree has a specific value, and we can initialize this value. So we could do def underscore init, and then we have self, but we also want to have each node is going to have a value. We're going to have a left value and then a right value. And what we can also do is we could set these values to default values. So just when initialized, we don't want them to be blank. So we'll set them as equal to none for now. So this would be our first node, which would be a default value of 0, and then left is default set to none, right is default set to none if there is no further specification or arguments that are being passed, but usually there will be. So let's say self.val. We need to set initialize each individual variable. Self.left equals to left. Self.right is equal to right. And there we go. There we created our basic tree node, and how an actual tree would look like is starting from the tree. We could actually start by creating this tree right now and how this would look like. So we'd have the root be tree node of 3, because we only need to pass in the value of 3, and left and right are set to none right now. But what we can do is to set the left value, we could just do dot left is equal to the next tree node. So to the left of 3 is 9. So we'll go tree node of 9, and then we can do root dot right is equal to tree node of 20, and root dot right, because the children of 20 is so tree node of 20 dot left. So to the left of 20 is 15, and to the right of 20 is 7. Is equal to tree node of 15 root dot right dot right is equal to tree node of 7. And there we go. That's how we construct our tree. Basically, this looks like in the formation of this, but what we want obviously is this specific output, outputting 3, 9, 20, 15 to 7. So, how are we going to do this? Well, one thing you might consider is that a level order traversal, going from left to right, there are two types of traversals that we actually did previously, remember, if you guys recall. There's a breadth first search and a depth first search. A depth first search is a traversal method where you go all the way down to the very last node, but then you come back up. Or there's a breadth first search where you go level by level. And if you notice, this level order traversal is a breadth first search actually. So a breadth first search uses what is known as a first in first out method, and that is typically achieved using a queue. So what we want to do is we want to create a queue, and Python has a handy library where we could just, from collections, we can import the deck or DQ. Deck, and from here we can create our queue by saying let's actually start by creating the function we need, level order traversal. So level order traversal, and all we need to do is take the root as the input, because we obviously don't need the whole tree. Like it said, given the root of the binary tree, return the level order traversal. So we only take the root as the input. We're going to have a list. This is going to be the final output that we want to have, so we're going to have it start out as this list, and we're going to hopefully make it into our output here. So what do we need to do? First of all, what we want to immediately consider is if the root doesn't exist, like for example, if the tree is empty, we can just return a blank list. So if we could say if not root, return result. So if it's a blank root and a blank root doesn't do anything, I'll just return it out right away, and we won't have to deal with that. Now let's set up our queue. Like I said, a breadth first search or a level order traversal uses a first in first out method. So what we are going to be doing is creating our deck here, and we're going to start our list with just with our list for the root. So remember, we're outputting this thing, so the first element in it is just going to be the root node. So now what are we going to do? We're going to say while queue. Now what does this mean? While queue essentially means that while there's an element that is in the queue, so we have something pushed into the queue right now, that means there's an element in the queue, a root, an object in the queue, 3. And when the queue is empty, essentially we want to break out of this and return result at the end. We could honestly already say return result, because that's what we want to do at the end. So when the queue is empty, we return it. Otherwise, we have to continuously take out the things that are being stacked in. So first of all, let's talk about level size. We'll make a variable for the level size is equal to the length of the queue. So how many levels our tree has. So right now it is at 1 because there's only one thing, and that's indicated by the number of things. So since there's only one level, we have only one element, we'll have a list called level, and it's going to be a blank list right here. So right now we're creating the next level of the queue, right? So now what we can say here is to fill out that level for I in range of level size, because we want to know how many elements are in the we need to loop through the entire queue. We want to get the leftmost element as the current. So what we want to do is we're going to set a current variable, and we are going to queue dot pop left. This is actually going to be the first element in the queue. So the first element in the queue, this is what the pop left command does, is it takes out the first element in the queue. So remember how we said breadth first search is a first in first out method at FIFO. This is why the root is the first element, and it's the first element we're going to take out as the current. Next, we can simply add it to the level list. So creating level.append current.val. We need the .val to get the specific value. And there we go. That's how we created the first, get the root out for the first thing in the list. And now we can simply say, at the end of this, obviously, we're going to say results dot append level. We're going to do this level by level, right? So, but we also want to consider the fact that we want to not only, if obviously if the queue is empty, it'll immediately break out, but if there are more things to go, we want to continue. So to continue, we can say if current.left. So we're checking if there is a left object in the queue, left element for the tree. If for example, if the root didn't have a left element, then we would stop right here. But since there is, we want to append it to the queue. So we could say queue.append current.left. We're appending the left node. And similarly, if there is a right node, current.right, we will queue.append current.right. And this way, the queue just continues going. For each level, it'll append the next two elements in the level. If there's a left element, there's a right element, it'll append that. It'll then go to the next element, and those level by level, the queue will fill up with the next level, 920, and then it'll append those to the queue and pop them out and add it to this level list, which we are going to continuously append to our final output, called result in this case. And now at the end of this, we return result.appended, and then when the while loop ends, we can simply return the entire list. And that's how we would create a level order traversal. So now we could test the code just to make sure we got everything right. Control S, and obviously I clearly forgot to print the result. Obviously, my mistake there. We are going to be printing out the level order traversal, the function we made, of the root. Did we? Yeah. Oh, shoot, sorry. I made this in the function, but obviously it's supposed to be out of the function. So we made that whole function, and now at the end we can print out the level order traversal we made and input this root, the same 3, 9, 20, 15 to 7. So hopefully we get this output, and if we run this code, that is exactly what we get. We get 3, and then we get 9, and then 20, and then 15, and then 7. And there we go. We can obviously expand this root to continuously test if everything is working, but the logic is sound. So hopefully you guys understood that demonstration of how to create a level order traversal in a binary tree. So thank you very much for watching this video, and hopefully you guys understood that. Thank you. See you. Bye.